Okay, this is Sergio Fernandez again, and this is another video as a placeholder. I put up the equation quickly, so it's out there. Then I put up another detailed video explaining how I got this equation. This equation has to deal with highly composite numbers. Highly composite numbers is kind of like the reversible prime. It's the number which has the most factors in it. Um, for example, 1 has one factor, which is 1. 2 has two factors, which is 1 and 2. 4 has three factors, which is 1, 2, and 4. 6 has four factors, which is 1, 2, 3, and 6, etc. So a a composite number is a number that has the most factors than any number that came before it. So 6 is a highly composite number because it has four factors, which is more factors than 1, 2, 3, 4, and 5 have. Um, I was not interested in getting the value 6 because I wanted to kind of come up with an equation for a ceiling for the factor equation that I had developed earlier. What I wanted to was the number factor itself. So when I put 1, I got a factor of 1. When I put 2, I got a factor of 2 for 1 and 2. When I put 3, I get a factor of 2, which is 1 and 3. When I put 4, I get a factor of 3, which is 1, 2, and 4. When I put 5, 5 has two factors, which is 1 and 5. But I want the highest factor so far. So instead of returning 2, which is the factor of 1 and 5, I return the highest factors that I found so far, which is 3. The factors the 4 has, which is 1, 2, and 4. So this equation kind of finds the highest number of factors so far in a given range. So if I put x for 100, it looks at the numbers between 1 and 100, and it tells you what was the greater number of factors found in any given number in that range. This is a little bit different than what most people want. Most people, if you give it a range from 1 to 100 or 1 to 6, they want to get the x value that actually gives you the most factors. Like if I put 6 between 1 and 6, 6 it should return 6 because 6 has 4 factors, and that's more factors than any other numbers before it. You know, 1, 2, 3, 4, and 5. The highest factors found in that range is 3 factors, which belongs to 4. So again, if I put 7, usually people want to get in a function the value 6 back because 6 has 4 factors, 7 only has 1, and 6 has more factors than the number before it. I wanted something a little bit slightly different. I didn't want to get the 6 back. I wanted to get the biggest number of factors found so far. So instead of getting 6 back, I wanted to get the number 4, which is 4 factors is the biggest factors found so far. That's what this equation does. This equation, you give it a range, 1 to 10, 1 to 100, 1 to a million. It sees how many factors each number has, 1, 2, 3, 4, 5, up to whatever range you give it. And it returns the biggest number of factors for any given number found in that range. So it's a little bit different from what people normally look for, but it's actually a function which is very useful to me since I was actually looking for an equation to find the ceiling for my factoring equation, which I had developed earlier. This equation can be modified slightly to actually get the number of factors back. So I could modify this equation in the future to actually, instead of getting, if I put a 6, instead of saying the biggest number of factors found was 4, it'll actually turn back the biggest number, the number that has the biggest factor is 6. So I could actually modify this equation slightly to actually get the number itself. But for now, this is the value I wanted to get back. So again, this is just a placeholder for a video I'm going to put up later explaining how I arrive at this equation. And what this equation does is it looks at a given range from 1 to x, and it returns the number of the greatest number of factors that any given number gave in that range, which is very close related. And I'm going to show you how what the jump is from this to the next equation, to the highly composite number equation, number function. Okay, a little modification of this and actually get the highly composite equation, which a lot of people seem to find useful. Okay, bye.